welcome to another WJEC A level physics question. This time is question 6 from January 2013's PH4 paper, and it's an orbits in a wider universe question, which is currently in unit 4. So we've got a light spectrum from a star 41 light years from Earth, and it was found that the light was Doppler shifted due to the star orbiting the mutual centre of mass of the star and a nearby planet, and the following graph is derived from the data obtained. And from the graph we've got to first of all calculate the period of the orbit in seconds. Well, the period is the time for one complete orbit, or one complete variation in the radial velocity. So if we read across to the next time when the velocity is the same as it was at the start, at roughly 13, then we're looking at about 44 days. So t is 44 days. So 44 times 24 hours in a day times 60 minutes in an hour times 60 seconds in a minute gives us an answer of about 3.8 million seconds. Next, we've got to show that the radius of orbit of the star about the centre of mass is approximately 1.1 times 10 to the 7 meters. So here we can use the relationship v equals 2 pi r over t. It's not given directly in the data book. You can imply it from v equals omega r, or just simply realise that this is speed equals distance over time, where 2 pi r is the circumference of the orbit and t is the time for the orbit. If we rearrange this for r, we got r is vt over 2 pi. The v we use is the maximum value that we see on the diagram, and if we read this we can see that that's about 18 meters per second. The period is what we've just calculated, and we divide by 2 pi. That will give us 1.09 times 10 to the 7, so basically what we were asked to show in the question. Next, we're told that the mass of the star is 1.9 times 10 to the 30 kilograms, and we've got to calculate the distance between the star and the planet, ensuring that we state any approximation that you make. So the approximation, whenever we get this type of question, is that the mass of the star is much greater than the mass of the planet. In other words, the total mass of the system m1 plus m2 in the formulae that we're going to use, we're just going to take it as being the mass of the star. So in this question we're going to use t equals 2 pi root d cubed over g m1 plus m2. That should be a 2, and that's going to simplify to t equals 2 pi root d cubed over g times the mass of the star. We square both sides, we get t squared is 4 pi squared d cubed over g times the mass of the star, and that will give us a d will be the cube root of t squared g times the mass of the star over 4 pi squared. So let's put in the figures. T was 3.8 times 10 to the 6 seconds. G is 6.67 times 10 to the minus 11. Mass of the star 1.9 times 10 to the 30 kilograms. All over 4 pi squared, and that will give us an answer of 3.6 times 10 to the 10 meters. For the last part of the question, we're going to use the centre of mass equation, or otherwise we're going to estimate the mass of the planet and compare it with the mass of the Earth. So the centre of mass equation is R1 is m2 over m1 plus m2 times d. Now we're going to use that same approximation here, that m1 plus m2 is the same as the mass of the star. So we've got m2d over the mass of the star. We're trying to find m2, so m2 is r1 times the mass of the star over d. r1 was 1.09 times 10 to the 7, or 1.1 times 10 to the 7. Mass of the star was 1.9 times 10 to the 30, and d was 3.6 times 10 to the 10. If we put those into the calculator, we end up with about 5.8 times 10 to the 26 kilograms. You can also do this, by the way, by not making the approximation, but that just makes the algebra a little bit harder and a little bit more time consuming, so it's just a waste of time in the exams. Anyway, we've got to compare this to the mass of the Earth, and if we look at the two figures, the mass of the Earth is 5.9 times 10 to the 24, this is 5.8, not far off 5.9 times 10 to the 26. So basically what we're saying here is that the mass of the planet is nearly 100 times the mass of the Earth. It's much heavier, or much more massive I should say, than the Earth. Thank you very much for listening. Please remember to like and subscribe, and feel free to leave any comments. Goodbye.